All right. Hello. Welcome to CFEngine's Agent is in webinar. Today we'll be talking about running CFEngine on IoT devices. My name is Craig Comstock. I'm a digger at CFEngine. That's my title, digger. I like to dig into things. So what we're going to do today is we'll talk about this, and then we'll talk about it for about 20 minutes or so, and then have some questions, and then they turn off the recording and have a more unstructured time to talk if we wish. Okay, so I'll go ahead and get started on running CFEngine on IoT. As I was talking about before we started recording, I feel like at this point I'm interested in running CFEngine on everything, kind of like I wanted to run Linux on everything about a little while ago. Which I still basically do. I try to run Linux on phones and all kinds of things. It's fun. So in order to run CFEngine on an IoT device, typically folks will use the Octo project to build an image.
Craig, what do you mean by IoT? Like
yes.
What's the bottom threshold here?
Internet of Things. Yeah, I don't even know what it means. What does it mean? It means small devices that that can interact with the world. I guess.
What's small? What do you consider small?
Right. Small. Well, I mean the Raspberry Pis, right? We've got a Raspberry Pi 4, got a Raspberry Pi 0.
So what are the hardware on these things? Like, because I was just reading, like, Raspberry Pi, whatever, 8 gigs of memory and
right,
2 gigahertz processor. It sure doesn't seem small.
Doesn't seem small. It's true. I guess it's been developing over time. Yeah, I was going to look for a couple of other things I have here, but yeah, you can get smaller with IoT. Obviously, I don't think I have them, but like a photon, particle, STM32 chip stuff. You can run like FreeRTOS or NutX is one that I've used a bunch. NUTTX. So it's just like a POSIX compliant small operating system that you can do things with.
Okay.
Yeah.
All right. Sorry to interrupt.
No, it's fine. Yeah, it's good question. Typically, I think the idea is that these devices are interacting with the world around them. They're small and don't require a lot of power, so they can get to places where other computers cannot. Connectivity is often an issue with like low bandwidth connectivity, maybe cell connectivity or LoRaWAN or other means, maybe periodic connectivity. So CFEngine seems like a good idea in this case because once you get a policy set on a device, it's there and it can fix things even when it can't connect to the like central server and things like that.
Okay. So what does Yocto do?
So Yocto, I am not super familiar with Yocto, but as far as I can tell, Yocto is a build system to build Linux images. It pulls in lots of projects, lots of repositories for different packages, and I believe it's written in Python. That's the clue that I've gotten recently when I get lots of errors trying to make things happen. And it creates images. It does not create a system that you can then interactively, do like apt update or apt install, that kind of thing. So you're kind of mostly stuck with what you build. Yeah, and in order to build, this is this Yocto project quick to build. So this is where I started. I tried to use something besides Ubuntu, but I ran into trouble. So I just did the default and used Ubuntu, installed some packages, git clone this, I don't know how to pronounce it, Pokey or Pocky. I think Pocky sounds better.
That's
like
right.
the Pocky sticks, that candy stuff. Yeah, so, and then get your branch. So they have various branches for like releases. So in this case, in this current case, hard knot is the kind of latest stable release, I believe. And then you do some commands, you source a file, and that gets you into this situation where you can use their command called bitbake, which can make several different targets. I've been doing this core image minimal. You can do core image SATO. I'm not really sure what this SATO means, but it's a UI environment. So yeah, I installed it once on one of my Pis, and I got things I could click on and stuff like that. You can also, so you start it by doing bitbake and the image you want, and then for fun, you can do it without hardware. You can just use QEMU to run that the image that you made. So I've got a situation here, Pokey source OE, and now it tells you what you can do. I typically make lots of little scripts that help me remember what to type. So here, for example, I've got something that will make the minimal image for the machine. That's the QEMU, and so I can run that. The first time you run this, it's going to take a really long time unless you have a really good machine, I think. I have a pretty decent laptop here. It's a Librem 15, kind of open hardware, open software, repair rights kind of laptop here. And it took probably at least half a day to build the first time. There's like 3,000 some packages that it builds. That was quite a barrier for me at first because I just felt like it wasn't working or something. It looks like it's doing some work. So as you can see here, I've got some other clues here on how to build for the various machines that I was targeting, which is the Raspberry Pi 0, the Raspberry Pi 2, the Raspberry Pi 4. After here, I've got the command, and then I added a couple things in here, serial, no graphic, so that, oops, sorry about that. I'll turn it off. I guess I have to kill Slack harder. So yeah, so the serial no graphic allows me to just have a terminal and do things like that. See if that works. Okay, so 71%. Let's go back to the stuff here. Yeah, at this point, they tell you how to customize your layer, customize your image. And typically what this involves is editing a couple of files. So this conf directory inside of build has layers that you can add. And so here I've started with these 3 layers kind of come standard. This one I had to check out a repository for, this one as well, and this one is one that I'm working on locally. So these are kind of the big projects that you can pull in. And so just for what it's worth, this one provides the machines that I was looking at for building for specific Raspberry Pis. This one provides an existing CFEngine recipe, which I have upgraded from 3.15.0 to 3.18.0. That includes both the core and master files. And then this one is my kind of work in progress for doing enterprise, CFEngine Nova. And Yocto does not come with my normal editor named Ed. So as you can see here, I got confused in Ed and typed :Q as if I was going to use VI. So sorry about that, snag. That's kind of fun. Okay, so then to configure, this file is rather large. You can set up all kinds of machines, all kinds of different options for various things, but the really interesting stuff here is at the end. So image install append, you append lots of different packages that you want to include inside of your image. And here I've included procps because enables CFEngine to understand processes and grep processes with its processes promises. Without that, it doesn't really understand that BusyBox is what's providing PS and it doesn't work properly. That's an issue I've run into on Termux as well as Alpine. So I'm well familiar with that problem. And then I put in a bunch of benchmarking stuff with the intention of kind of both benchmarking the hardware as well as CFEngine's performance on the devices so that I can kind of have like things to compare against. Here you can see this is the meta open embedded recipes for CFEngine, CFEngine master files. I actually already have CFEngine Nova working, so I won't show that much today. OpenSSH is just so I can get into the box afterwards, and so I don't have to have a screen. And then here, I was playing around with trying to get Wi-Fi to work, but it's just not, I don't know what the secret recipe is. You would think that adding a feature of Wi-Fi would just make everything work, but apparently it doesn't. And then down here, I found that, so because I'm doing this minimal image, it makes the image rather small. So the Yocto kind of by itself takes up about, I think it's about a gig almost. And so there's almost no space left for kind of creating the databases and stuff that we need to do enterprise work. The community version didn't need quite as much space. So here I just add kind of the maximum recommended space from our docs, which is 500 megabytes. They say that our recommendations say you can get away with maybe 100 to 250, depending on what you're doing, right? Depending on how many things you're inventorying or various other factors. So that is the configuration for things. Now we'll come over here and see if our build is done. Yes, it is. Okay, so now I can, this is really great for debugging things, so you don't have to bother with flashing an SD card and doing everything. So you can just run QEmu. This will boot up based on that image and go along. Takes about 11 seconds or so. By default, you can just log in as root with no password. Kind of feels like Alpine in that regard. We'll get here eventually. There we go. Oh, and actually this part, so it's actually recommended that you pre-generate the stuff because it can take quite a bit of time and you want to have that stuff pre-generated so you can coordinate. Yeah, typically you would not install SSH daemon probably. Okay, so root, and I'm in. Okay, so CFEngine, we have CFEngine? Yes, we do. And yeah, okay, this is enterprise, but the meta open embedded layer is available right now. You can get 3.15.0. I think it may have a few bugs, but I think it basically works. And I'm going to submit the 3.18 upgrade to upstream here soon once I kind of polish it up. So at this point, we know that we have CFEngine. That's great. So I'm going to, control AX. Yeah, okay. There we go. So there's that. And now here I've got a Raspberry Pi 2, which I might be able to show. It's here. So Raspberry Pi 2, and then my little breadboard with some buttons and LEDs to debug GPIO stuff. I've got a little voltage divider thing to interact with this distance sensor, which is something we'll get to next time. So we can see that we've got Linux on Raspberry Pi 2. Again, we've got enterprise. I've already bootstrapped this device, so there is a bit of a bug where everything's in var libntech, which is a library that we use that we created for core. We kind of split off commonly used things into the libin tech, and we've dealt with this bug before, so there's must be something in the auto tools that's fouling that up. Yeah, you can see that on Bootstrap, this is my policy server. I've got some policy in here. So the policy comes with stuff to monitor file changes. So I'll make a change to something that probably shouldn't be changed, and CFEngine will notice it. It's changed. Okay, so yeah, so here we can see that Etsy services has changed, and we're going to report on that file change. We can back that out and see that it changes back. And then I'll show one more thing, which is service promise. I actually didn't do a service promise because the server that we're basically got init scripts here. The one service that seemed to be running was udevd, so I chose that one. So I'll kill that udevd and then run policy, and it should repair that for me. So we can see that we have CFEngine running on an IoT device, a Yocto build, and that we can bootstrap to a policy server, and we can make it do normal CFEngine things like restarting udev. So the reason I couldn't use the services promise is because the binary udevd is different than the service name. So that was a little too complicated for me to get up for a demo. Yeah.
Nice.
And
so
yeah, that's pretty much all I have to show for today. I think next time we'll show using Enterprise and using this distance sensor here to maintain the health of our most esteemed colleague, the doer of things, Nick Anderson. Because both Nick and I have these desks that you can push a button and the desks move. We're doing it together in opposite direction. Okay. So anybody have any questions? Man, Nick, that was not even planned. That was awesome. Good job.
I know, it's good. Yeah.
I don't have a question necessarily, but back to sort of the definition of Internet of Things, right? I think generically from a plain Jane mom and dad, non-techie person, I think Internet of Things generically means any sort of thing that connects to the internet, right? So it doesn't have to be a Raspberry Pi or an Arduino or something like that, but it could be your thermostat or your washing machine or your refrigerator, right? Anything that's got some sort of ability to talk out to the internet, and that's where you come up with all the security concerns and that sort of thing. So what do you think about that kind of definition as far as like a generic sort of statement?
Yeah, I think that's right. I mean, and to that end, I mean, we've got people running CFEngine on all kinds of interesting things. So some trams and buses, payment turnstiles, smart displays, things like that, where you walk up to the bus station and then you interact with that digital sign to figure out where, what route you're going to get on. There's a lot of that stuff that's got CFEngine kind of running under the hood, keeping things working, making sure that they're doing the things that you want them to do. Works really well in this distributed, disconnected type of environment. And most of those things are running Linux, which stuff.
Do you know, is anybody doing stuff in automobiles with CFEngine?
I don't, yeah, well, yes, I do. And there are, but I wouldn't be able to talk about it. And I don't know, I don't know for certain. So I know that in the automotive industry, like, yes, CFEngine is used, but I am not certain that it is used, for example, like inside of a head unit. Like I know, like down in Australia, there are some trams and buses and things like that, and CFEngine is running on some of these things to help keep those things connected and provide like Wi-Fi to the passengers and things like that. There are some manufacturers that I know, vehicle manufacturers that are running CFEngine for some things, but I don't think that in those cases that I don't think that we yet have CFEngine being shipped from vehicle manufacturers as part of the thing that you're receiving. But even if I did know, I probably wouldn't be able to tell you. It's kind of the nature of our typical customer.
That's fair. I understand, Nick.
Sorry. Is there anything like, so, I mean, I assume some of you guys are nerds too. I mean, kind of curious what kind of sensors and stuff you are playing with at home, or if anybody has sensors and things like that that they're using at home to kind of make some automated stuff. I mean, I've, through the pandemic, like many people, the jungle grew inside my house, and been thinking about more automation there. I mean, lights are sure one thing, but maybe it's time that I need to get into some humidity sensors and water level sensors and nutrient level sensors. And, to me, that just sounds a whole lot easier to do in CFEngine's DSL, because I have access to combine all these different contexts and express that. But
I want CFEngine to automate my watering and grow lights.
I do too. Anybody else got sensors at home?
I don't have my CFEngine environment plugged into it, but yes. So I made my own garage door sensor, and I've got it tied into Nagios. So if the door is open after 8 o'clock, I get a text message. And I also have, I made my own sump pump water level sensor. So if the water level gets too high, same thing, I get a text alert. And I have some work in progress on a sensor to monitor the heating elements in my hot water tank. But I haven't gotten to play with that in a long time. So, but I've got some framework out there.
So what kind of stuff, like, CFEngine is very much around state management, right? And you've got that hooked up to like Nagios to wake you up in the middle of the night. Like, what would you want to react on based on some of those sensors? I know that, like, CFEngine being the distributed way that it is makes it, a good fit for stuff like, a truck that's rolling across the country and like entering different regions, and then for whatever reason needing to use that GPS data to reconfigure the uplink, right? Maybe you need to force it onto a different network or force it down to a different speed or whatever. But those kinds of things you can do with CFEngine. You don't have to have connectivity in order to make those types of changes at the edge. Those changes can just happen based on the information that the agent can get from those local sensors.
Yeah, just thinking of the garage door scenario, right? It would be nice if CFEngine could send something to the opener that says, "Hey, close the door," which, again, back to the Internet of Things, right? A lot of garage door openers are, smartphone enabled, so that would be something cool. Just thinking outside the box right there.
Yeah, cool.
Yeah, it reminds me of like the kind of if this then that kind of stuff where you like tie together various services and things like that. Yeah.
Yeah.
Yeah. So the garage door sensor is connected to a Raspberry Pi, and that one is pretty old. And when at the time, I don't think I was able to track down a new enough CFEngine version for that. This has gone back like maybe 5 years. So, and then the other sensor that I have in my sump pump is connected to an Arduino. So, you know, that's a little bit different of a scenario. So, yeah.
Craig, what's the smallest thing you've got CFEngine running on right now?
I probably had it running on a watch that I had for a while in Termux, an Android watch. Yeah, I certainly plan on trying to get it on like a NetX device. So those are, you know, pretty small.
Exciting.
I'll definitely run it on my my Rock phone when I build that. Yeah, so next time we'll look at the same kind of stuff, but at the mission portal side of things, we'll look at sensor data going into mission portal and charts and graphs and things like that. Yeah, so until next time, we'll stop
Thanks
recording and
coming.